Chapter 1, Section 4 in Algebra, we're looking at powers and exponents. So the first thing, the power has a base and an exponent. So what we're talking about for those is a power is going to be something like this here. The base is the 3, it's kind of at the bottom. You build on your base. The 5 then is the exponent. So I'm going to quick write that in there just so we have it written down for posterity. So this here is going to be the base, and that is going to be the exponent. And if we're talking about area, going back to, we're kind of going to tie area and volume into these whole powers or into exponents type of thing. But if we're talking about the area of a square, well, a square, the side lengths typically we say are length s, because they'll be the same. We can use the same variable. So area is going to be s times s, or we said a equals s squared. So that's why they'll call it squaring. If you take something and you're going to the second power, they call it a square because it ties into kind of the area of a square. When we're talking about cubing something, here I have a cube, a three-dimensional object. We're going to say the sides are all length s on that. And when we have that, the volume is going to be the length times width times height. So I'd have s times s times s. Well, if you're multiplying s by itself 3 times, that's going to be s to the third. Or you could say s cubed. And maybe up above I'll write s squared. That's because now going back down to my bottom one, the volume of a cube is given by something to the third power, the side length to the third power, if all the sides are the same length. So that's where these words squared and cubes come from. Now, fortunately, we don't have like names for all kinds of things, but 3, or just 3 to the first, is just 3 to the first power. 3 to the second power is called 3 squared. I'm pulling this out of your book, page 27, this chart. And where we go down then to the third power, 3 to the third is 3 cubed. When we start getting like fourth power and fifth power, they don't have special names for those, at least not that I know of. So they'll just say 3 to the fourth, 3 to the fifth, and so on. If there's one thing that I want you to get from today's section, this is it. This here is hugely important. This is going to be the thing that most often people mess up on if they make mistakes in here. Actually, there's 2 things. This is one of them. So the base is only, all in caps for dramatic emphasis, what's immediately before the exponent, unless there's parentheses. Or at least some sort of grouping symbol. In other words, this first thing here, if I have 3 times 2 to the fourth, the common mistake is people will either multiply the 3 and 2 together and say that equals 6 to the fourth, or they'll take the 4 and they'll say, oh, it's 3 to the fourth times 2 to the fourth. But the base of that 4, the base of the exponent, is only going to be what's immediately before. The base is just the 2. In other words, another way to look at this is though you have 3 times 2 times 2 times 2 times 2. That 2 to the fourth is saying 2 times itself 4 times, and I have to do 3 times that. Now, when we get parentheses, something like this next example, where I have 3/5 to the second power, well, now the 2 is going to apply to everything inside the parentheses. So this one here becomes 3 squared over 5 squared, which is the same then as 3 times 3 over 5 times 5. I suppose we might as well finish it off. That becomes 9 over 25. And if we wanted to finish off that top one, a lot of people do 2 times 2 times 2 times 2 in their head, then multiply by 3 or start with a 3. This is kind of how I'm going to group it. makes it a little bit easier. That both of those 2 times 2's gives me a 4. So I really have 3 times 4 times 4, which is the same as 3 times 16. So that's 30 plus 18, so 48. But anywho, we don't need to worry about doing that in our head necessarily right now. But I just like seeing problems finished. But okay, moving on. So if we have now letters, we have variables in there, this x, y to the third. Don't let that mess with your head. A lot of times people, they see the variables and they start panicking and then they start screwing things up. But just kind of treat it like you would a number. The 3, the exponent, applies to just the y, just the thing immediately in front of it. It's kind of like really that first example. Maybe I shouldn't have went up so high. That you could look at this as though it's 3 times 2 to the third, or I have the 3 instead of a 4 there now. But when we have that, the 3 just applied to the 2. Same thing here, the 3 just applies to the y because the x and y are separate things. So this really just becomes a x times y times y times y. That I have y times itself 3 times, and I do the x times that. Moving on to page 2. This is something I don't want you to stress about, but I want you to be aware of. And if you're using a different book, this is somebody I don't know, this may not even come up in your thing. But when you have this negative 3 to the fourth, the question is that negative part of the 3? Is it negative 3 to the fourth? Or is it negative of 3 to the fourth? I was always taught that it's that first way, negative 3 to the fourth power. So if you have something like this, negative 3 to the fourth, I was always taught it's negative 3 to the fourth, so negative 3 times negative 3 times negative 3 times negative 3, which gives you 81. The Texas Instruments graphing calculators, they do exponents right to left. So they look at this problem here. They look at it as though it's 3 to the fourth and then negative 1 times that. So I was always taught in punching an even exponent of a negative number into a graphing calculator to make sure that you put parentheses around the negative. And that's how I'm going to continue to teach it. So you're forcing it to do it this way. I think they actually call it reverse Polish, the programming language for the Texas Instruments calculators. So anytime you do a negative number to an even power, put the negative number in parentheses. Or you could know it's going to end up being positive. You learn that perhaps a little bit later on and just kind of drop the negative. That gets a little dangerous, start dropping things. But it's always safe to put it in parentheses. Our book is the first math book I've ever seen in all my years of teaching, which is more than I'd maybe like to admit. But in a long time. But okay, so it's the first book I've ever seen that treats this as though it's a negative 81. I would just ignore those because that's totally different than what I've seen for years and years and years. I chose to not assign those problems, so it shouldn't come up, but just kind of wanted to make you aware of it. So don't stress about that at all. Here's the point in one thing. If you have a negative number to an even power, push comes to shove, a negative number to any power, just put the negative in parentheses before you punch it in. It'll work. We can talk about it in class if you want. Okay, here's the other common mistake, and I saw it when we used to do these RTI tests in class all the time. The first one was something like this, and people just right out of the gate, boom, they look at it and they think 2 times 4, and they say it equals 8. So you have to kind of program your brain to, it's like exponents, it's multiplication, but it's 2 times itself this many times, 4 times. So you don't just multiply those numbers, it's not the same as 2 times 4. 2 to the fourth is 2 times itself 4 times. And you can do the math kind of however you wanted to, but kind of how I wrote it here was I'm looking at it as though 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. But anywho, that's it for this section. So we have the assignment listed here at the bottom, unless I gave you something different in class. And kind of the points of this section, what we're supposed to learn is this here. That's what you might get quizzed on soon. So have a great day. Let me know if you have questions, if you're one of my students.